This fourth video of the first chapter deals with the golden rule of savings in the solo model. The aim of this video is first to help you find the optimal savings rate in the solo model, optimal in the sense of the one that maximizes consumption per individual at the steady state, and as well these videos should help you to better understand the link between the savings rate and the capital per worker at steady state. So first I want to remind you the dynamics of capital per efficient worker in the augmented solo model with population growth and technological change. So you have the law of motion that we'll use later on in this video. The specific question that I'd like to answer here is the following. We want to know which savings rate allows consumers to enjoy the highest consumption at the steady state. In order to answer that question, we need an expression for consumption per efficient worker. So this C tilde star is expressed as Y tilde star minus I tilde star, where I denotes investment per efficient worker. So this consumption, C tilde star, can be written in another way as F of K tilde star, so production, minus investment, which is equal to savings, so which is equal to S, the savings rate, times the production, F of K tilde star. So we have an expression for consumption per efficient worker. The thing that we are looking for, this savings rate here that allows to achieve the highest consumption, is referred to as the golden rule rate of savings. The upcoming second part of the video aims at giving you a way of computing this golden rule rate of savings. Before we actually compute this golden rule, there's one thing that we need to take into account, namely the fact that the savings rate and the amount of capital per effective worker that we reach at steady state are linked. So S and K tilde star have a connection. Indeed, a way to see this is to use the fact that at steady state the variation in capital per effective worker is equal to 0. So using the law of motion for K tilde star, we'll write that SF of K tilde star is equal to delta plus G plus N times K tilde star. This formula in turn is equivalent to writing that K tilde star divided by F of K tilde star is equal to S over delta plus G plus N. So here in this formula there is a clear link between, on the left hand side, an expression that only takes into account capital per effective worker, K tilde star, and on the right hand side of the equation an expression that only takes into account the savings rate plus some exogenous parameters. The link is very straightforward in the Cobb-Douglas case, because here the production function, or output per effective worker, Y tilde T, is equal to K tilde T power alpha. So this expression on the left hand side boils down in steady state to K tilde star power 1 minus alpha, which is still equal to S divided by delta plus G plus N. So with this equation, there is a very easy and direct link between K tilde star and S, and it's actually quite easy to get S as a function of K tilde star or K tilde star as a function of S. So the way that we'll find the golden rule here is that we're not going to look for the golden rule in terms of the savings rate, but we'll use this fact that I've just talked about, that S is linked to K tilde star. So we'll try to maximize consumption, C tilde star, as a function of K tilde star directly. So we'll write that C tilde star is equal to F of K tilde star minus the savings term, SF of K tilde star. And then we'll use the property of the steady state that states that in steady state there is no variation of capital, so savings is equal to the capital dilution plus depreciation term. So C tilde star now in steady state is equal to F of K tilde star minus delta plus G plus N times K tilde star. So now we only have an expression of C tilde star which depends on K tilde star. So in order to find the maximum of this consumption, we're going to use the first order condition. So the derivative of the production function F prime of K tilde star should be equal at the optimum to delta plus G plus N. Now, an important thing that we need to do with this first order condition is to try to find an interpretation. At the steady state, if you increase by a marginal amount the amount of capital per efficient worker in your economy, you're going to get a marginal increase in production, which is measured by F prime of K tilde star. So this marginal increase in production can be used for consumption. But on the other hand, if you try to increase your level of capital in this economy, you're going to have to sustain the capital because you're still at steady state, and so you'll have to invest more in your economy in order to counterbalance the negative effect of capital depreciation and capital dilution. So you know that at optimality your increase in K tilde, so in K tilde star, is neither good or bad, because the marginal increase in production that you'll get, so in consumption, will be exactly compensated by the dilution and depreciation effect. So you might ask, why does this give me the golden rule now? Well, now you only have an expression that gives you the marginal productivity of capital at the steady state as a function of some exogenous parameters, delta, G, and N. But you can actually invert this relationship, that is, write K tilde star as another function of delta, G, and N, which are supposed to be known in the economy that you're interested in. So you'll have an expression for K tilde star, and in turn this will give you the savings rate S that you need at the golden rule. So as an exercise, I just ask you to take the case of a Cobb-Douglas production function, so where y tilde t is equal to K tilde t power alpha. So in this example, I'm just asking you to first find the optimal value for K tilde star, and then show that the optimal savings rate in terms of consumption is simply S equals to alpha. So we've now reached the end of this fourth video about the golden rule of savings. So you should now be able to find the golden rule rate of savings in the Solow model, if need be, by computing first K tilde star at the steady state. Be sure as well that you understand the interpretation of the final result, and don't hesitate as usual to ask me questions or make some comments either on Moodle or at the end of a lecture.